3.6, the inverse and contrapositive of conditional statements. Before we get into the thick of things, what I want to do is just write down a question or write down a conditional statement. If a number is even, then it is divisible by 2. So let's dissect that a little bit. We know that this is going to be our hypothesis. This is going to be our conclusion. So if I can label it, this is P and this is Q. So we're going to come back to this, but we'll come back to this in a little bit. So the not notation, the way that we would say it is not P. This right here just means not. So we would insert not in the portion of the conditional statement. It is attached to. So for example, not P, this one right here would mean that there would be a not in the hypothesis. The inverse is a statement formed by negating both the hypothesis and conclusion. And we keep it in that order. Okay, so we would say not P implies not Q. So in this example here, so if this is our original conditional statement, if a number is even, then it is divisible by 2. The inverse of that statement would be if a number is not even, then it is not divisible by 2. Now the contrapositive also uses nots. So the contrapositive is a statement that is formed by negating both the hypothesis and conclusion of the converse statement. Now, you don't have to write this down, but remember the converse is P, that's the conditional. The converse from yesterday was Q implies P. So, when we negate both the hypothesis and conclusion of a converse statement, it looks like not Q implies not P. So in the case of the example that we have here, we would say, if a number is not divisible by 2, then it is not even. Now I'm just going to go back in here and add some color, just so that you can see. So this is still related to the P, just with a not. Okay, whereas in the contrapositive, the hypothesis comes second. Okay, and in inverse, we have it's not divisible by 2. Okay, the not is added, but this is still the bulk of the conclusion, but it goes first in a contrapositive statement, so we switch. What I want us just to write down right now is the converse. No, do you know what? We're just going to go off to the side here. So, conditional. P implies Q. This is just a quick little review. Converse is Q implies P. Inverse, not P implies not Q. And contrapositive, not Q implies not P.